again. We're still working on benzene, and having done the side where they give us a picture and we pick the name, we're now onto the other side where they give us the name and we get to draw. So I hope you like hexagons. Our first task is methylbenzene. So our primary is benzene. That's just a hexagon. We almost never ask you to actually draw like the C's and the H's and all these for benzene, so feel free to use this shortcut. It's not cheating or anything. So that's my rotten-looking benzene, and it has a methyl group attached to it. So any one of these can be carbon number 1. I'm going to go off to the side just to prove that I can. There is methylbenzene. They didn't have to say 1 because, of course, it's number 1. 1,3,5-trimethylbenzene. Let's see if I can make a slightly nicer hexagon here. Pen's not helping me much, but okay. And we have 3 methyl groups, and they go on, we'll do carbon number 1, not 2, there's 3, nothing on 4, and there's 5. And if you want to go top, bottom right, bottom left, that's fine too. Also, if you draw your benzenes with a flat side on top instead of a point, not a problem. It's benzene anyway. So you're not going to mess it up by drawing it at a funny angle. Okay, 4-phenylheptane. Our primary is not benzene. It's a heptane. So 1, 2, 3, 4, 5, running out of space, 6, 7. Okay, there's heptane. And on carbon number 4, they want a phenyl group. So 1, 2, 3, 4. We go line, and attached to that is a benzene. Okay, awkward. If I had just done a line structure, I'd be done right now. Since I put these C's here, though, I owe you some hydrogens. So if you're going to write this, remember, every carbon has 4 arms, so this carbon, I could see 2 of the arms were being used there, so that means it has 2 left to hold hydrogen. Same thing. This carbon has 3 bonds active, so it's only got room for 1 hydrogen. And then we get CH2 and CH2, and as usual, at the tail end of an alkane chain, we get a CH3. So if you start doing a structure like this with the letters in it, you're kind of stuck doing the hydrogens, or it'll look weird. 2,3-diphenylnonane. Okay, so having just hosed myself with this, I'm going to smarten up and just do a line structure for this one. Nonane, 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9. That's all we need for nonane. On the second carbon, there is a phenyl group. On the third carbon, also a phenyl group. Not super proud of that hexagon, but I hope that makes some sense. And 1,3-diethylbenzene, so benzene's our primary. 1, 2, 3, 4, 5, 6. Don't forget the circle. Without the circle, it's cyclohexane, and we don't want that. Okay, our first carbon has an ethyl group on it. And our second has nothing. Third carbon has an ethyl group on it. Something like that. And if you want to put CH2, CH3 on each of these, that's fine. I just went line structure because it's a bit faster. And last one, we have a benzene. What are the ornaments this time? Carbon number 1 has a methyl group. Let's go down here and be different. There's a methyl group, and then this is 2, this is 3, this is 4, and that gets a propyl group. CH2, CH2, CH3. 3 carbons is propane, or in this case, a propyl. Not too bad, I hope.